Okay, welcome back dear students. Let me continue the electron spectroscopy. So I wish to discuss about the spin multiplicity of the electronic state. So in connection with the electronic microscope, electron spectroscopy, the term spin multiplicity is important because it is a parameter that represents a particular electronic energy level in terms of spin multiplicity. Okay, spin multiplicity of an electronic state is defined by an expression that is equal to 2s plus 1. So, okay, so study this. The spin multiplicity of an electronic state is defined by the term 2s plus 1, where s is the total spin of electron, total spin of the electron present in the molecular species. Okay, it is the total spin of the various electron present in the molecular species, that is usually represented as S is equal to summation of ms. Okay, where ms is equal to plus half or minus half. So it's the algebra, there is a summation of these various ms of the electron gives the total spin of the electron in the molecular species. Therefore, spin multiplicity is defined by the term 2s plus 1. So in the case of a species in which the electrons are paired, so we have a electronic system, so molecular system, in which all the electrons get paired in a particular energy levels, then in that case S is equal to always plus half plus minus half, that is equal to 0. So in the case of any molecular species in which all the electrons are get paired in a given molecular system called a molecular orbital. You know that in the molecules the electrons are occupied in the molecular orbital. The electron level, the energy level in the molecules are called molecular orbitals. So if the molecular orbital contains electrons in the paired state with the opposite spin, then resultant spin S is equal to 0. Therefore, in that case, spin multiplicity of such a state is paired electron state is paired electron is equal to in same energy state, same energy level. The same energy level that is represented by plus or minus 1 like this. This is the situation. So they are in the same molecular orbital, same MO. Then we have that is 0, therefore 2 into 0 plus 1, that is equal to 1. That state is called a singlet. This situation is called a singlet. The situation in which the electron are paired in a particular energy state, that is called a singlet. So we have to remember that the spin multiplicity can be mainly classified into 3. One is singlet, and other is doublet, and third is triplet, that I am going to discuss. The situation in which a same energy state or level, that is called a particular molecular orbital, is occupied by 2 electrons with opposite spin, that is always possible according to Pauli's exclusion principle, then the resultant spin, the total spin as capital S is equal to 0. That situation is multiplicity is 2 into 0 plus 1, that is 1, that is called a singlet state. If that is in the same molecular orbital, that is called a singlet S0, that is called the singlet 0, that is called the S0 ground state. If this special situation is called S0, that is, if the electron get paired in the same molecular orbital, that is usually happen in the stable state, that the ground state of the molecule. The ground state of the molecule, the singlet ground state of the molecule is usually represented by S0, that is called a singlet ground state. Okay, singlet ground state. Suppose one of the electrons get excited by suitable excitation with the UV and visible radiation. This one of the electron may get excited to the higher electronic level with preserving the spin as such. Okay, this is parallel, this is anti-parallel. So on excitation, it will be excited by reserving the same spin level like this. Okay, it is excited to this level like this, that is, and this is called, that is, in this case situation, it is still anti-parallel. Okay, the situation is anti-parallel, but in different MOs. That is the different MOs. So here also it is a single state. That is 2 into 0 plus 1. That is 0, but it is called a triplet excited single state. It is called an excited single state. The situation is known as an excited single state, S1. That is excited single state. Similarly, the molecule may have excited that is another excited single S2, S3, etc. That may be like this. Okay, excited that is S2 state may be like this. This is the S2 state. So the single state may be of two types. One is a ground state. Usually molecule exists, that is in the paired spin state in the same molecular orbital, that is 0, that is the ground state. All other excited state are, all other single state are excited state, S1, S2, S3, etc. That can be attained by suitable excitation by UV and visible absorption of light. Okay, suitable frequency, UV and visible light is radiated to the molecular system. The one of the electron is excited by reserving their spin. Okay, inversion is usually not possible during the excitation, so they undergo excitation by keeping the spin same. So that is they attain the anti-parallel spin in the excited single state. Then another state is, suppose the situation is such that the total spin of the nucleus is such that it contains unpaired electron, one unpaired electron. If the molecular system contains one unpaired electron, then S is equal to either plus half or minus half. Either plus half or minus half. In that case, if a molecular species contains one unpaired electron, then S is equal to half. That situation is 2 into half plus 1, that is equal to 2, that is called doublet. That situation is called doublet. That happened in the case of free radical. Okay, free radicals in doublet state and suppose a molecular species contains two unpaired electron with the parallel spin in the two different molecular orbitals like this. That usually happens from S1 to T1 intercross I0. This is the situation. This is called a triplet T1. Okay? The situation is such that a S in that case is half plus half, that is equal to 1. Here S is 1. Here S is 1. Therefore multiplicity is 2 into 1 plus 1, that is equal to 3. So the spin multiplicity here is 3. The spin multiplicity is the total spin of the electron S is 1, then the spin multiplicity is 2 into 1 plus 1, that is equal to 3, that is called triplet. The state is called a triplet. So, spin multiplicity can be of any of the three types. S0, the ground state, always there, and an addition to S1, S2, etc. So, singlets. The next stage, that is anti-parallel spin. So, the spin momentum, total spin is equal to 0, the situation. The next is doublet, in which the molecular species have an electron with a half spin. And there is other molecular species in which the electron spin has 1, that is a diradical situation. Okay, that is S is 1, therefore spin multiplicity is 3, called triplet. This is so. A molecular species can have singlet, doublet or triplet can be possible. According to the spin multiplicity is possible. Out of which S0 is the ground state. And other S states are X1, S2 is excited state. Similarly, T1, T2 as the triplet states are also always excited state. The important thing is that a molecule or excitation directly undergo transition to S1, S2, S3, etc. and from which it undergo that is interconversion to T1, T2, etc. Each S1 state, excited state is accompanied by corresponding T states which are slightly lower in energy than corresponding S1. Suppose this is S1 state, okay, there is T1 state also, that is like this. This is the S1 state, so this is the T1 state. Here, there is a definite probability that in the single state, there is a chance for spin inversion occurs for a moment. There is a chance for S1 state to undergo spin inversion to this type, and this is called T1. This is a more stable state than S, even though it is an excited state. This excited state is more stable than S1, so it is lower, slightly lower energy than S1. Okay, because the repulsion, since they are of parallel spin, they always away from each other. Okay, the distance repulsion T1 is slightly lower than. Then similarly, we have S2 state, S2, like this. Corresponding to which there is T2, like this. So T2 undaga. Okay, like this. This is T2. It is slightly lower energy than T1. And even though, okay, I come to the spin conservation rule, that is a quantum, that is in the electronic spectroscopy, there is a selection, quantum mechanical selection rule, that is spin conservation, that is spin conservation rule എന്നാണ് അറിയപ്പെടുന്നത്. Okay, I will come to that aspect. The electronic transition is governed by spin conservation rule. Okay, spin conservation. അതിലേക്കാണ് നമുക്ക് വരാൻ പോകുന്നത്. The excited electronic state, quantum mechanical selection rule, that is spin selection rule എന്നാണ് അറിയുന്നത്. Spin selection rule അതിലേക്കാണ് വരാൻ പോകുന്നത്. അപ്പോൾ നിങ്ങൾ മനസ്സിലാക്കുക, a molecule can directly convert to S1 level from S0 because it is spin allowed transition. Then from S1 it can change to T1 even though it is forbidden, spin forbidden with a name. It's a probability is there from S1 to T1. Next, we have to discuss the quantum mechanical selection rule. Quantum mechanical selection rule. That is a spin selection rule എന്നാണ് അറിയുന്നത്. Spin conservation selection rule. Spin selection rule. So the electronic spectroscopy is governed by the spin selection rule, that is a quantum mechanical selection rule for electronic spectroscopy, the spin selection rule, which says that the transition between any two electronic level is allowed or possible if delta is equal to 0, or that is, there is no change in their multiplicity. So according to the spin selection rule, those transitions are allowed between any two electronic states in which the spin multiplicity is same. On the other hand, if the two electronic states are of different spin multiplicity, then the transition is forbidden. Then the transition is forbidden. That rule is called the spin selection rule. So according to the spin selection rule, the transition between electronic transition is always take place. Electronic transition always takes place only between two states of same spin multiplicity. According to the spin selection rule, the electronic transition always takes place only between two states, electronic state of same spin multiplicity. That means delta S. Delta S should be equal to 0. Delta S should be equal to 0. That is, this is called a spin allowed transition. Spin allowed. Okay, for example, S0 to S1, S1 to S2, etc. T1 to T2, T2 to T3, etc. Similarly, D1 to D2. All these are spin allowed transition because here the spin selection rule is conserved. Okay, where delta is equal to 0. So, according to this selection rule, that is transition between any two electronic states takes place only between the two states having the same spin multiplicity. If they are of different spin multiplicity, that's delta is equal to not 0. Delta is not is equal to 0. That is called spin forbidden. That transition is spin forbidden. That electron transition is spin forbidden. So we have two types of transition: spin allowed transition and spin allowed forbidden. That is, delta is equal to 0, that is called spin allowed, and delta is not equal to 0, that is called spin forbidden. That is spin forbidden transition are. That is S1 to T1, spin forbidden. Okay, then okay, this is a mainly spin forbidden, or T1 to S0 transition. All these are spin forbidden transition because a transition takes place between two states of different spin multiplicity. They are generally called spin forbidden. But even they are forbidden, there is, according to quantum mechanically, there is a probability for occurring this process at a slow rate. Okay, at a slow speed. Low rate and slow rate നടക്കുന്നുണ്ട്. Phosphorescence example, even to zero radiative transition is a process which even though it is spin forbidden. Similarly, S1 to T1 IAC, inter-system crossing, also takes place. That is also spin forbidden, but it takes place with a small speed. Okay. This is a situation. So, I will explain the quantum mechanical selection, that is called a spin selection rule. Okay. That is, the equation is delta is equal to 0. That is, spin electronic transition takes place only between two electronic states having the same spin. That is, delta is equal to 0, and that is called a spin allowed. If delta is not equal to 0, that is called a spin forbidden transition. The next is the terminology chromophore and oxochrome. Chromophore and oxochrome is the term. Okay, that is an isolated functional group that present in a molecule not in conjugation with any other group. that can cause the selective absorption of radiation at a particular frequency, okay, is called a chromophore or light absorbing group എന്നാണ് chromophore എന്ന് പറയുന്നത്. That is a functional group that is responsible for the absorption of light by a molecular species. Okay, so that it undergo pi to pi star transition, n to sigma transition. This is a characteristic transition. N to sigma star, pi to pi star, and n to pi star transition. നടത്തുന്ന ചില functional ഗ്രൂപ്പുകളെയാണ്. So there are certain isolated function group or isolated groups in a molecular species which are not in conjugation with any other group. Okay, which are not in conjugation with any other group. അതുകൊണ്ടാണ് isolated. An isolated functional group or independent functional group that is present in a molecular species which is responsible for the absorption of light at a particular frequency, okay, is called chromophore. Mainly this group arises, okay, causes the transition due to n to sigma star, pi to pi star, and n to pi star transition. So they are group responsible of this type of transition. Example are the species N double bond azo group, then NO2, then double bond O, okay, carbonyl group, then CN, cyanide group, then COH group, okay, COH group, then C triple bond group C double bond C. All these are suitable example of chromophore. So this is already known. Diazo group, they have strong color. The nitrochromate has yellow color. So all these groups have characteristic coloration. They can absorb light at a particular frequency due to this type of this type of light. Into sigma star and pi to pi star and to pi star transfer responsible and the group are. So an isolated functional group that present or independent functional group that present in a molecule which cause the absorption of the light at a particular frequency is called a chromophore. There are light absorbing group in a molecule and they absorb light due to this kind of transition. Any of the three type of transition will through the UV and visible light. UV and the visible light is absorbed. Then oxochrome. Oxochrome are another group or functional group or atom which when present along with the chromophore can shift the intensity of the light to a greater, okay, they can increase